Okay, hello, my name is Mauricio Salazar, and I will explain the two methods, two classes that we made to complete the assignment 2 of the project. The idea is that we have a set of data, a training data, that is the 9 bus voltages and angles of a 9 bus system. And we have a data set that we have to train and to cluster. And then we have a test set that we have to cluster after we train with the first data set. So the idea of the program is that we start with the k-means with the testing data set that we will explain right now. So this is the class. The class has the property to normalize the data that we are inputting, and we can define the tolerance also that is to stop the iterations that I will show you later. And then we have the options to input the data as a CSV file or from a list or from a database. Okay. So basically, when we run the class and we construct the k-means class, we are reading the data and then we are normalizing it. Okay. And then we also run with the method of k-cluster which type of clustering we are using. For this project, we have 3 of them. We have the Forgy, we have the random, we would have the Euclidean one. Okay. So when we select the Forgy method, the idea is that we run it with the Forgy centroids method. We select randomly data from the objects from the data set that we are training, and we are assigning it one cluster name. So the method is here. Okay. So here's random init, and we are taking random object from the data set completely, and then we start the clustering like this. Now in the random centroids method, we are assigning for each object, we are assigning a cluster number randomly. So all the objects will have a cluster number. And the Euclidean method, it was like a method that we came as a good solution for this data set specifically, because what it does is that we made all the distance of all the objects with respect of the origin, and then we are selecting the lowest, the minimum distance object and the maximum distance object as a centroids, and then the other centroids we are selecting in a distance between them. So in this method, we are started the centroids like very spread in all the clouds of the dataset. We'll see some examples of running all these different methods and the outputs that we have with the program. Then after we have selected the methods, we go through the distance and clustering of all the objects that we have in the dataset. So we have this very big while loop right here that it will run all the time until set of tolerance error that we predefine and it will comply. What doesn't mean this self-tolerance is it will take the absolute movement of each centroid, the Euclidean distance that is moving each centroid. And if a centroid doesn't move like this value of the tolerance, it will stop all the iteration. So the way we calculate these centroids coordinates is that we take the original table, and we have then the centroids that we already selected with the method before, and we compare it each centroid with all the data objects with this method called distance and clustering. And the distance and clustering, we have it here. Okay. So this is the loop to calculate the distance. So we are taking each value of each centroid and compare it with each object and calculated the Euclidean distance. And we are creating a dictionary that it will tell for each centroid and all the, in this case, 200 objects will be saved that value. And after we create all this information of distances and in the centroids, we are then sorting that dictionary to take the maximum and the minimum value of the distances, and then we are appending that to the table. So in that way, we are selecting the closest one. Okay. So after we calculate the distance, we have already a new set of centroids. So the idea is that we have another method that will calculate the distance between the old and the new centroids that will give an output of the error. And that will continue until everything is stopped. So as you can see here in the output command window, we run this program using the 4G method. So the idea is that we selected 4 clusters in this example, and what it's doing for the 4G method is is randomly selecting 37, 40, 110, and 30C objects for these centroids, that is these clusters. So the initial values when for these objects of the centroids, it will be these ones. And then when it starts the iteration, it will start to calculate the movement. So this is the movement and the new set of objects with respect of the other centroids. As you can see here, there is an error that is calculating all the absolute Euclidean distance between the old centroids and the new centroids. And until it gets the tolerance, in this case with 0.01 of tolerance, it will stop the iterations. So after 2 iterations for our case, for the 4G method, it will stop. So more or less, we made an output with a print method using the matplotlib of Python to see all the 18 variables that we have, the angles and the voltages of each bus. And as you can see in the 4G clustering is working properly. The centroids move to the clouds, to the data sets. That is pretty clear in the map, in the figures. Where is it? Okay, and then we have down here the status or the selected criteria that we already did. I will show you how we did this. So after clustering all the data, now the next step was to label the centroids. That is, we are selecting for each centroid that we already calculated the coordinates, what is the state of the naive buses. So what we selected was some range looking the angles. That is the most obvious attribute that you can select where is the state of all the 9 buses, the 9 bus case. So in the case of the generator down, that we analyzed if you want to see in the Word file the reasons why we select that generator down, is that for one bus, in this case the maple angle bus, that is right here, if the data set of the centroid, in this case that is the CN1, is between these numbers of angles, it will select it as generator down. The same goes for the other selected buses, and then you have the labeling of the centroids that is plotting down in the figure every time you're running the program. Okay, which else we have here? And the thing is that we have an additional methods that we only use in the development of the program, and it's not used anymore. So the print answer project is the only method that we are using to print it. That is practically is the matplotlib library being used to plot the beautiful answers that we have. And you can see here an example of execution of the class that we use in this case. That is, we are using our data set. We have 18 attributes. In this case, we have 18 data of voltage and angles. The cluster number that we selected, it was 4 because we have 4 states. The tolerance, the normalization, and the input of the table that we are using the list already given by the by the data set, by the database. I think that's it.